Serial 75 just survived a brutal 388-second burn at McGregor, simulating the full ascent punishment that Starship's three inner Raptors endure from liftoff to orbit. That perfect blue-white flame proved these engines are ready for real flight conditions. But here's what shocked the industry. SpaceX spotted the very first Raptor 3 on August 3rd, 2024, and now they're already testing Serial 75. How did they go from one prototype to mass production in barely over a year? Let's dive right in. The answer lies in SpaceX's relentless testing philosophy. Many of those early Raptor 3 prototypes didn't survive. They went boom during brutal stress tests. But that's exactly the point. Every explosion taught engineers something critical about metallurgy, combustion stability, and thermal limits. By the time Serial 75 fired up, SpaceX had already learned from dozens of controlled failures. What separates SpaceX from traditional aerospace companies in this approach? During the Flight 11 broadcast, SpaceX revealed that their first flight-ready Raptor 3 engines were just entering acceptance testing, with serial numbers only in the 30s. Fast forward to now, and we're seeing engines in the 70s completing long-duration burns. That's roughly 40 engines built, tested, and validated in a matter of weeks. The manufacturing velocity is staggering. SpaceX is churning out these 280-ton thrust monsters at a pace that would make traditional rocket manufacturers dizzy. Here's what makes this production surge even more significant. Flight 12 needs 39 Raptor 3 engines total, 33 on Booster 19, and 6 on Ship 39. With serial numbers already past 75, assuming most pass acceptance testing, SpaceX isn't just meeting demand. They're building a stockpile. This means redundancy, faster turnaround between flights, and the ability to swap engines quickly if issues arise. Could this be the key to achieving their goal of daily Starship launches? Now let's talk about what makes Raptor 3 an absolute beast. This engine delivers 280 tons of thrust at 350 bar chamber pressure. That's 350 times the pressure in your car tires, all contained in a combustion chamber running at 3,500 degrees Celsius. When you multiply that by 33 engines on Super Heavy, you get approximately 9,000 tons force of total thrust at liftoff. That's nearly 90 million newtons of raw power, more than 2.5 times what Saturn V could produce. And Saturn V sent humans to the moon. But here's the kicker. Raptor 3 achieves nearly double the thrust of Raptor 1 while being lighter, simpler, and more efficient. SpaceX even ditched the old heat shields entirely, streamlining production and reducing failure points. The engine's full-flow stage combustion cycle runs cooler at 500 to 600 degrees Celsius, meaning less wasted energy and more fuel throughput. Think of it like upgrading from a gas-guzzling muscle car to a high-performance hybrid that's somehow even more powerful. SpaceX isn't stopping at 280 tons either. They're already designing Raptor 3X variants aiming to break past 300 tons, force with only minor tweaks, no massive overhauls required. Scale that to 33 engines and you're looking at 9,900 tons force of thrust, nearly 10,000 tons of controlled fury. But there's always a trade-off in engineering. When you push thrust higher without changing engine size or fuel type, something has to give. What does SpaceX sacrifice to achieve this raw power? The answer is efficiency, and it all comes down to nozzle design. Each Raptor 3 has a fixed 1.3-meter diameter, and SpaceX needs to fit 33 of them tightly on Super Heavy's base. To make that work, Raptors run in what's called an underexpanded configuration. Here's what that means. A rocket nozzle is designed to expand exhaust gases fully for maximum efficiency. This is called ideally expanded. But since the diameter can't grow anymore, the nozzle isn't as wide or long to fully expand those gases. This underexpansion increases thrust because gases exit faster, providing the thrust density needed at Super Heavy's engine cluster. However, it's less efficient because not all energy is extracted from the exhaust. Using these sea-level Raptors with underexpanded nozzles all the way to high-altitude costs Starship around 5 to 10% payload capacity compared to engines with larger nozzles optimized for thin air. That's thousands of pounds of cargo that could reach orbit. So why would SpaceX deliberately accept this penalty? Because reusability demands it. Those underexpanded nozzles aren't just about ascent, they're critical for landing. If you make the nozzle wider for better expansion, you need a longer skirt to protect it. That adds weight and severely reduces gimbal range, the amount each engine can swivel to steer. Raptor's 15-degree gimbal range is absolutely essential during the dramatic flip maneuver when the booster rotates to land. A shorter, underexpanded nozzle keeps that range wide open for precision control. There's also pure mechanical advantage. A smaller nozzle isn't just lighter, it's stronger, better able to resist cracks or warping from insane vibrations when 33 engines fire simultaneously. Larger, fully expanded nozzles could bend or catastrophically fail under that brutal stress. And when engines need to reignite after coasting through space during a landing burn, that smaller nozzle makes airflow smoother and more predictable, reducing chances of turbulent combustion or choking. This is vital when you're trying to catch a 230-foot booster with Mechazilla's arms. So SpaceX made a calculated choice: prioritize reliability and thrust density over perfect fuel efficiency. Sure, you lose some payload capacity, but you gain something far more valuable: engines that work flawlessly across every phase of flight. To counter the efficiency loss, SpaceX upgraded Raptor 3's turbopumps, the heart of the engine that spins at insane speeds to force fuel and oxygen into the combustion chamber. The new pumps feature integrated plumbing and smarter design, squeezing more performance from the same fuel flow. Inside the combustion chamber, tiny changes make massive differences: denser subcooled fuel, precise nozzle tweaks, and chamber pressure increases from 330 to 350 bar. Each marginal gain adds up. These improvements push Raptor 3 closer to that 300-ton threshold for future 3X versions. It's engineering at the bleeding edge, where every bar of pressure and every degree of temperature matters. But SpaceX isn't alone in pushing these limits anymore. At 11 p.m. Eastern Standard Time on December 2nd, Landspace, a private Chinese aerospace company, launched its Zhuke-3 rocket from Jiuquan Satellite Launch Center. Standing 216 feet tall and built from stainless steel, Zhuke-3 runs on methane and liquid oxygen, just like Starship. Sound familiar? The mission was partially successful. The second stage reached orbit, but the first stage hit trouble during its landing burn. It lost an engine mid-descent and crashed in a fiery explosion. Despite the failed landing, Landspace called it a success, saying expected technical objectives were met. Telemetry confirmed thrust control, attitude control, and recovery trajectory all worked as planned. The booster nearly hit the bullseye at the landing site. For a first test flight, that's impressive. How does this compare to other first attempts at landing? Remember, even SpaceX took multiple tries to stick the first Falcon 9 landing, over 2 years of intense testing and dozens of controlled descent experiments before they nailed it. Blue Origin's New Glenn just attempted its first landing too. In that context, Landspace getting this close on Flight 1 shows serious engineering capability. China is proving it can stand shoulder to shoulder with the world's top players in reusable rocket. And they're moving fast. Landspace already made history as the first company worldwide to reach orbit with a methane-fueled rocket when Zhuke-2 succeeded on its second flight in July 2023. Now Zhuke-3 represents their next generation, a low-cost, high-power, high-frequency reusable vehicle. On its maiden flight, Zhuke-3 delivered over 17,600 pounds to low Earth orbit even after reserving propellant for booster recovery. That makes it the largest and most powerful commercial rocket ever launched from China. Landspace isn't stopping there. They're planning an upgraded Zhuke-3 with stronger engines and larger propellant reserves, boosting payload capacity to over 40,000 pounds in reusable mode. Their long-term goal: reuse each rocket up to 20 times to deploy China's satellite internet constellations. From methane fuel to stainless steel construction to propulsive landing attempts, Chinese engineers are mastering the same cutting-edge tech that SpaceX pioneered. In some areas, they're catching up surprisingly fast. What does this mean for the global space race? So what does Serial 75's 388-second burn really tell us? It's proof that SpaceX has cracked the code on mass-producing the most powerful methane engines ever built. From that first prototype on August 3rd, 2024, to churning out engines in the 70s, all while pushing thrust to 280 tons and chamber pressure to 350 bar. This is manufacturing at a scale the aerospace industry has never seen. Flight 12 is going to be historic. Ship 39 and Booster 19 will carry 39 Raptor 3 engines into battle, marking Starship Flight 3's debut. We're talking about 9,000 tons force of thrust at liftoff, nearly triple what took humans to the moon. And with SpaceX already eyeing Raptor 3X variants capable of 300-plus tons, the ceiling keeps rising. But they're not racing alone anymore. China's land space just proved they can build methane-fueled stainless steel rockets, attempt propulsive landings, and deliver serious payload to orbit. They're learning fast, iterating faster, and closing the gap. The space race isn't just heating up, it's going hypersonic. When nations and companies push each other this hard, we all win. Faster innovation, lower costs, and humanity's reach extending deeper into the solar system. What's your take on Raptor 3's rapid evolution? Think SpaceX will hit 300 tons with the 3X variant? Drop your thoughts below. I read every comment. If you found this breakdown valuable, smash that like button and share this with fellow space enthusiasts. And don't forget to subscribe to Space Update 24 hours so you never miss the latest developments. The future is launching faster than ever, and we're covering every second of it.